Any questions on that so far? No. All right. So this tells us that this left to right on the interval from, I guess you could say from 0 to 2, or from 4 to infinity, or positive infinity. Okay, and we know it's right to left. On the interval from 2 to 4. Okay, so we're going to use that to graph it. Okay, so if we want to sketch it, of the particle, you want to start at t equals 0. Okay, so if we have our sketch here, give it a little bit of space so we can work out everything up there. And we'll actually have this -4, 0, 4, 8, 12, 16, 20, 22, 24, and 28. Okay, so we'll kind of sketch that there. Okay, so to find out where the particle is at t equals 0, we just need our position function. Okay. Uh-oh, CT-ION. Okay, so P of 0, and if we remember our position function, actually, if we wanted to, we could use, might as well use that. So t to the third minus 9t squared. So we have 0 to the third minus 9 times 0 squared plus 24 times 0 plus 4. All right, so we know that that's going to equal, since that's 0, and that's 0, P of 0 is equal to 4. So when t is equal to 0, you're at 4. Okay. So we already know at 2 and 4 is when the velocity stops. So we want to know what values or what position is the particle at 2 and 4. So what is the position when the velocity equals 0? Okay, so we know that P of 2 is equal to, let me see, 2 to the third minus 9 times 2 squared plus 24 times 2 plus 4. Oops. And I already worked that out. Where did I put it? I think I, for some reason, shuffled up my notes, because I don't feel like working it out again. Here we go. Okay, and that actually works out to be 24. Okay, now we want to find out where it is when t is equal to 4. Which is 4 to the third minus 9 times 4 squared plus 24 times 4 plus 4. Okay, so working that out, we know that P of 4 is equal to 20. Okay, so we have our P of 0, was where we started. And we know it goes to P of 2 all the way to 24. Then it stops. Then at 4 seconds, it goes to 20. Okay, so just from up here, we know it's going to the right from 0 to 2. So from 0 all the way to 2, since this is our t equals 2, and this is our t equals 4, from 0 to 2 is going to the right. Okay, and we know from 2 to 4 is going to the left. So it hits 2, stops, goes back here, and we know from 4 to infinity is going to the right. So it hits 4, stops, goes back the other way. So you can draw a little arrow there if you like, kind of a direction arrow. Okay, so that's the path of our particle on a straight axis. All right, any questions on that one? Kind of lengthy, but hopefully the steps weren't too bad. All right. So one more. Where's my? Make sure I got my right next example ready. Here we go. All right. Okay, so this next part's going to kind of take us back a little bit. Okay, so we're just going to define the amount of change of a function, well, it should be of f of x. Clean that a little bit. Can be found on the interval, let's say x and x plus h, where the change in y will give us, and we know our amount of change will be f of x plus h minus f of x. Okay, so we're kind of going back a little bit. Okay, we also remember that the average rate of change can be found using, okay, so our average rate of change is actually our slope of the secant line, which is f of x plus h minus f of x all over x plus h minus x, or if you wanted to simplify it a little more, f of x plus h minus f of x all over h. Okay, so that would be your average rate of change between those 2 points. Okay. And let's say we also know, and let's say at some point A, let's say number could be anything, but we'll just say at some point A, that equals the limit of f of a plus h minus f of a all over h as h approaches 0. So for this one, we just made x equal a. Okay. So if we made h really small, because remember, I don't want to take any space on the paper, but if you remember that the limit as h approaches 0 is just h just keeps getting closer and closer and closer and closer and closer and closer. So those 2 points just get closer and closer. But instead of letting them get closer and closer, let's say if we just pick one really small point and say that's our h. So they're just that far apart. It's not getting any closer. Then if it's that close, then we know that if h is almost, that's the key word, infinitely, because you can't be infinitely small, then we can actually see that our f of f prime of a is really close to our f of a plus h minus f of a over h. Okay. They'll be really close to being the same value. Okay. So that means if we multiply both sides by h, so if we have h times f prime of a, equals f of a plus h minus f of a. Okay. And now if we add f of a to both sides, so that would give us f of a plus h. Oh, actually, that should be an approximation, not an actual equal sign. Equals f of a plus f prime of a times h. Doesn't matter which one's first. Okay, and we can use this to actually approximate the value of f of a plus h. Fine. Oh, move that up some. F of a plus h. Either I'm writing too hard or these leads are soft. If we know f of a, f prime of a, and h. All right, so let's say, for example, okay, so let's say if we know that the population of a city is tripling every 5 years. Bless you. Okay. So if the current population is 10,000, what will the population be in 2 years? Okay, so they don't give us a position function or population function. They don't really give you anything to work with but this. But we can actually make it work. Okay, so we'll let P of t represent our population. In thousands. Let's say t years from now. Okay, so instead of working with 10,000, we'll just work with 10. It'll just make the math a lot easier. Okay. Now we know that as of right now, the population is 10,000. So at t equals 0, the population is 10,000. So P of 0 equals 10. So remember, that's just your 10,000. Since as of now, the population is 10,000 when t is equal to 0. Remember, t is equal to 0 is where we're starting. So as of right now, this very moment. Okay? And it's also said that after 5 years, it's going to triple. So if it's 10,000 now, and after 5 years, that means that 5 years is going to be 30,000. So since the population triples after 5 years, P of 5 is equal to 3 times 10,000. So our P of 5 is equal to 30,000. Remember, that's just our 30,000. We're just writing it in a smaller number to deal with. Okay, so remember, you can use f prime of a is equal, keep forgetting my approximation, a plus h minus f of a all over x plus h minus, well, a plus h minus a. Okay, so we can actually use that to find our f prime of, or p prime of 0. So p prime of 0 is going to equal to our a plus h is actually 5. Minus p of 0 all over 5 minus 0. Okay, so we're just going from 0 to 5. That's all the information we have. Okay, so we know our P of 5 is equal to 30, or 30,000, minus your P of 0, which is 10,000, all over 5 minus 0, which is just 5. Okay, so you have 20 over 5, which is 4, or 4,000. So P prime of 0 is equal to 4. Okay, so we have our P of 0, P of 5, P prime of 0. Okay, so now we can use that to actually estimate the population after 2 years. Okay, so using f of a plus h is approximately f of a plus f prime of a h. We're just going to write it as p, because remember, we're looking for 2 years. We have 2 years is going to equal, let me kind of write in parentheses, from now, t equals 0, to 2 years from now, which is t equals 2. Okay, this is what we're approximating. Okay, so if we're looking for our f of a plus h, which is 0 plus 2, so you have your 2, equals f of a, which is, in this case, p of 0, plus f prime of a, which in this case is p prime of 0, times h, which we're going from 0 to 2, so our h is just 2, or times 2. Okay, so we know our p of 0, which we solved up here, is 10, plus p prime of 0, we solved that already, that's 4, times 2. So our p of 2 is going to be approximately 18. So that means after 2 years, we're approximating the population will be around 18,000. So after 2 years, should be I guess you can say not approximately 18,000, or estimated at 18,000, whichever way you wanted to say it. Okay, so this would be your final answer. Okay, so it's kind of one of those take what you do know to figure out what you don't know kind of things. So we knew where we were at 0, we knew where we were going to be after 5, so we can take that and figure out where we're going to be at 2. All right, any questions on that one? All right, so we will stop there.